Okay, so hi guys, Louis here. So in this video, we're gonna begin with the chapter 3 of Math Grade 10. So the first lesson is about quadratic relation. So in this video, I'm gonna introduce for you uh, the formula of that and how can we solve some problem related to this. Okay, let's move to the first definition is quadratic relation. So what is quadratic relation? As I mentioned here, is a relation of the degree 2, which is it will have a formula of ax square plus bx and plus c, where a is different from 0. If Because if a is equal to 0, this will become the linear relation, and this is the same that we learned in chapter 1 and chapter 2. So it needs to be different from 0, and the a b c is the coefficient in this formula. And the quadratic relation will have the shape like the U shape like this. It's called parabola. This can face upward or facing downward like this example. So as long as it's at the shape like this is the quadratic relation. Okay. So let's try our first example. Which graph appear represent a quadratic relation? So in this one, the first one is we can easily see that it's a linear, right? So this is not a quadratic relation. So I give it x, which means no, right? And in the second, it had a parabola, which like what I mentioned before is quadratic relation. So this one is a quadratic. So give it a tick. But in this one, it had the V shape like this. It's not like the same U shape like what we learned, right? So this one is not. I give it X. And this one is not a quadratic relation because the quadratic relation need to be facing upward like this or this. This will not be like this one. This one is not a quadratic relation. So this one is not. So I give it a tick. And this one is look like this one, but it's facing downward. So it's also a parabola, which means is a quadratic relation. So give it a tick. And last one, this one is a straight line and some straight line form there. It's kind of seem like similar to quadratic relation, but in this situation, it's not a quadratic relation. So after this, we just have two examples, which is C and D is the quadratic relation, and all of the others are not the quadratic relation here. Okay. Okay. And I just want to quick mention about the linear relation that we learned in chapter 1. The linear relation is the linear. It's a straight line. And I have the table here, which is x is equal to minus 1 is this point, and x is equal to 0, which is this point, and x is 1 is this point, and x is 2 is this point. And this form a straight line, which respect the y is equal to 0, 1, 2, 3, respectively. Okay, and what do we learn about today? How can we differentiate the quadratic relation and the linear relation? So this I will quick mention about the next definition is differences. So in this we will learn about first differences and second differences. And in the first part, this will be the first. So the first differences are the differences between the consecutive y value. And the symbol is delta 1. Okay, so in this, is it the differences between the consecutive y value? So this and this is the consecutive y value, right? So we need to calculate the differences between that. So 3 minus 1 is equal to 2, right? And the same with order. These are also consecutive y value. So that means in this, we will calculate like 5 minus 3, which is equal to 2. So I put 2 in here, and the last one is 7 minus 5 is equal to 2. So I put 2 in here. And another caution is if the x value change by equal intervals and the first differences are the same. Remember this, there are two clauses in here. The x value change by equal intervals and the first differences are the same. So we can conclude that that relation is a linear. So in this one, is it a linear? We already see the x value change by equal interval, which is plus 1, plus 1, plus 1, right? So, and all of the delta 1, which is first difference, are the same. So we can easily conclude that this is a linear. Okay, so and how about the second differences? What is this used about? So let's move to second differences. Okay, second differences are the difference between the consecutive first differences value. It's just different from the first differences is the first differences calculate from the differences from the y, but this is directly differences between the first different. Okay, so let's try this one, and we need to calculate the first differences and second differences. Okay, so in this, I already got this one is 1 minus 0, which is 1, and this one is 4 minus 1, which is 3, and this one is 9 minus 4, 9 minus 4, which is 5. All right, so I put 5 here, and here is 16. 16 and minus 9 is equal to 7. So I put 7 here. Okay, and let's calculate the second differences. So we need to calculate the same as what we learned previous about first differences, but we calculate on this value. So here, the first is we take 3 and minus 1. So that will become 2. And here we take 5 minus 3, this will become 2 as well. And lastly, 7 minus 5 is also equal to 2. Right? So, and what is this used about? I have this one. If the x value change by equal intervals, like same, by equal intervals, that means the x change need to be equal. It's not like it will be like 0, 1, 2, 3 is the equal interval, but like 1, 2, and 4, this is not changed by equal intervals, right? Okay, and the second differences are the same, so we can conclude that the relation is the quadratic relation. So is this a quadratic relation? We just check, right? So 1 plus 1 is equal to 2. So 2 plus 1 is equal to 2. So this is also plus 1 equal to 4. And 4 plus 1 is equal to 5. So the x values here are changed by equal intervals. And the second difference are all the same, right? So we can conclude that this is a quadratic relation. Okay. Let's try some example. So example 2. Okay, calculate the differences from a set of data and determine whether the relation is linear or nonlinear. If the relation is nonlinear, determine the second differences and identify the quadratic relation. So this question is asks us to do two things. This is linear or non-linear. And the second is, if it's non-linear, check the second differences. And is that a quadratic relation? So let's do it together. So A, I put the same number is sorry, X is 10 and 20, 30 and 40. So Y here's 21, 41, 61 and 81. Okay, so let's calculate the first differences first. So 41 minus 21, 41 minus 21, which is 0 and 20. So this is 20. And 61 minus 41 is 0, and this one is 2, so it's also 20. And then lastly, we take 2 of this, minus 61 is 0 and this 2. So this also 20, right? And the thing here we need to check, we already see like the first differences are the same. And the second thing we need to check is their x value changed by equal intervals. So this one we can easily see that. Another color. Okay, so 10 plus 10 is equal to 20, and 20 plus 10 is also equal to 20, and 30 plus 10 is also equal to 40. So the intervals here are same. So we can conclude that this is a linear relation, right? Okay, and let's try the example D. With the example D, I got x is 0, 1, 2, 3. Y is equal to 1, minus 1, 7, and minus 11. Okay, so in this, we just do the same thing. Like we calculate the first interval. So minus 1, minus 1, minus 1 is equal to minus 2. And 7 minus for negative 1 is equal to 8, right? And minus 11, negative 11 minus 7 is minus 18. So in here, we need to calculate the second differences. I already got 8 here. So 8 minus for negative 2 is equal to 10. And minus negative 18 minus 8 is also is minus 10. Oh, I'm sorry, is minus 26. I'm sorry, like minus 18 minus 6 minus 8 is, so it's 6 and become 26. Okay, yes. So in this, we already see this are not the same, and we continue to calculate the second differences. It's also this not the same, which is here. So we can conclude this is not linear, and also not a quadratic. Okay. So let's try another example. In this the thing we need to do is just calculate the first differences and see that are they the same. If they're not the same, we continue to calculate the second differences to determine whether it is a quadratic relation or not. Okay. So the last is this a quadratic relation? So if the question asks us to about quadratic relation, we need to calculate the second differences. So I put the number in here. X is 0, 1, 2, 3, and 5. So 1, 2, 5, 10, 17. So at first, to calculate the second differences, we need to calculate the first differences first, right? So the first differences is here's 1, here's 3, here's 5, and here's 17 minus 10 is 7. And right here, I took the same value, like 3 minus 1 is equal to 2. And 5 minus 3 is also equal to 2. And 7 minus 5 is equal to 2. Right? We are to see this one is the same. 2 is equal to 2 and equal to 2. Right? And we usually conclude that this is a quadratic relation. But take a look in here. Are the x value changed by the same interval? Right? So 0 plus 1 is equal to 1, right? And 1 plus 1 is equal to 2. And 2 plus 1 is equal to 3. But in here, it's need to plus 2 to with 3 to equal to 5. So the intervals here are not the same. So in here, we cannot conclude that this is the quadratic relation though. So this is not a quadratic relation. So remember, whenever you check whether it's the linear or quadratic relation, we need to check, does it have the same x? Does the x or the x value have the same chain intervals to determine that? Okay, and with that for today, I'm done for today. Thank you for listening. If you have struggled in that, you can contact me through Facebook or Gmail or Instagram, which I attach in my description. Thank you for listening.